Thus far, coding of the event handlers has really been of a sequential nature. The computer executes each statement line by line, and we followed this route of getting input, performing some process, and displaying output. And there may be multiple steps in each one of those. We might be getting several pieces of input, performing several steps, and displaying multiple pieces of output. But we follow this process in a sequential nature. As we begin to make more robust programs, the sequential structure just won't properly perform what we need our applications to do. We're going to introduce a structure here called a conditional structure. And we're still doing the input, process, and output, but now we're going to do a step where we're asking a question or evaluating a condition, and if that condition is true, we're going to perform another process. If it's false, though, we won't perform that process. In Visual Basic, there are 4 different conditional structures. The simplest is the if-then condition. So we have an if keyword, then our Boolean expression that we're evaluating is either true or false, the keyword then, and an end if, and in between the then and the end if, we're going to have code to execute if that condition is true. If that condition is false, that code will not execute. So let's take a look at an example in Visual Basic. I have a very simple application here in which the user enters an integer, clicks the evaluate button, and is told if the number is either even or odd. So I put in 20, I'm told that's even. 43 is odd. Let's take a look at this simple application. So I have a text box named txtnum, a button named btn evaluate, and a label named lb output that contains the text of enter a number and click the button. Let's take a look at the code for our evaluate button. So I'm dimming my num as an integer, and it's going to equal the value of txtnum.text converted to an integer, or cast as an integer. Then I've got status as string equals even. So I'm going to say by default, I'm expecting my number to be even. Then here is the conditional using an if-then. If my num mod 2, that's the remainder of the integer division, so I'm dividing the number by 2, and if it's equal to 0, it's an even number. So if it's not equal to 0, I'm going to set status to odd. Now if that number is even, that status equals odd, that statement will never execute. We hit the end if, and then my output is an interpolated string of my num is and the status either even or odd. We could put this in a try-catch structure just to make sure the user enters an integer value. So if they enter something other than an integer, or that couldn't be cast as an integer, such as ABC, we'd have a message box that comes up that says there appears to be a problem with your entry. Your entry must be an integer. Just to demonstrate that, let me run this again. So if I were to put in, let's just say an X, I am told there appears to be a problem with your entry. And the entry must be an integer according to the title. So again, if I put in 7, I'm told that's odd. And 12 is even. So that's just another demonstration using the try-catch when you're getting input from the user. If I'm writing something for myself, I'm probably not going to do. If I'm writing a program for myself, I may not use a try-catch. I'm going to assume that I'm always going to put in the right data entry, but somebody else may not. That's how a very simple use of if-then, where the condition may or may not be met, and this code may or may not execute as a result. If you just jumped into this video, you can see all the videos from the Programming Practicum playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos I create, you can click my picture in the top right to subscribe to the channel.